Okay, so let's learn about recursive and tail recursive. The left one is recursive, the right one is tail recursive. So as you can see, the normal recursive is basically it has to deal with the stacks and it has to remember where the function info is, and so that we can return back to where we came from, right? So when we call function within the functions, the stack have to remember the function info, and that create a big large of memory, and it just bloated with the function info. And however, it has a good reason so that we can return back to where it came from. So in this case, um, n equal to 4, and for we have an expression called factorial, right? So okay, let's look at the code first. We're gonna program the code first, and then we will see how it makes sense. Okay, so we have a recursive and tail recursive. And right here we will be using factorial, right? So the n factorial is going to be equal to n times n minus 1, and that will be n equal to 4. So n will be equal to 4, and n factorial is 24, right? So this will be our uh, expectations. So now we're going to use a variable called answer equal to 0, number equal to 4, and then a will be our starting point. We're going to need that for tail factorial later. So it will start from 1. Okay, so we will have receive basically the answer from a function called factorial. Uh, let's just say fact recursive. Okay, and then this will we will pass the number, and then right here we will print, so don't forget printf, uh, basically fact recursive, right? So e, and then let's put the new line there, and answer, right? So that will be our print statement. Okay, so let's copy this functions and then paste it right here. So right here we will be uh, int, and then my value int. Now let's copy this functions. So this will be our function prototype inside our source.h, and don't forget to include the standard input output IO, right? So and also include that source.h in our .c function, .c file, sorry. And then right here we will write the logic of the fact recursive function. Okay, so the logic. So now, as we can see in our recursive diagram, at some point we will hit n equal to 1, and that will be our end of row, right? End of the wall, and we will have to return back, right? So that's why uh, we have to write the logic that we can return, right? N equal 1 or n is less than 0, right? So if n is number, right? Number is less than 0, then we will return with 0. Yeah, less than 0, then we'll return with 0. Else if in some point number is equal to 0, or number is equal to 1, so we will have to return 1. Okay, so that will be our second case. All right, and then if nothing else has happened, and if number is greater than 0, then we will continue calling the recursive functions. So in this case, we will use the formula right here. Okay, so return, and then number times fact recursive, and then we will basically number -1. So that's our formula from here. So let's see if this works out perfectly as we expected. So Control F5, and it worked perfectly. There you go. So um, it returned back. So n will be equal to 1, um, and it will return right here and multiply by the previous expressions result, and then after that, the expressions result will be the input of the next expressions, and the input will be another expressions, and then we return to the end of the where we came from, right? So which is 6 times 4. N is 4, so it will be 6 times 4 is 24. Okay, so let's move on to the tail recursive. Very similar to the recursive itself, but in this case, we only going forward, which is winding phase, and we don't go back to unwinding phase. We don't go back there. So, which is why the compiler remember this is tail recursive, and it doesn't have to remember anything about the functions info, right? It just keep track of only the parameter info, and it just overrides it on the top of the previous function info. So which is why a little less consuming about the memory resources, and it is preferred way in our uh, programming. Okay, let's go to our tail recursive. So basically, we will copy the same thing right here. Let's copy this, and we will change number here. Start. Uh, it will be the start variable will be sorry. It will be a. Sorry. So that will be a starting number, right? And we will call this tail the fact function, right? So and then we will say tail factorial recursive. Okay, it should be the same answer, but a different type of um, logic. So okay, so let's go first here. So let's here copy this int, int, and then int. So our functions look like this. Okay, and let's copy all this function here and paste it here. So now we can write the logic. Okay, so the logic is similar to this. I copy and duplicate here, but we will change, right? So number less than 0 will be 0 still, but is if it's equivalent to 0, then we will return um, 1 right here. Um, okay, and then we will have else if it's equal to 1, then we will return a, which is right here. The reason is basically we can we this will be the final answer, right? uh, Very different from this normal recursive functions, because in this case we are returning the expressions, but we are doing the uh, as we return we are calculating the factorial. But in this case we don't have to return. It will just We don't have to return where we came from. uh, Nothing like this, right? So this right here, we just return the answer, the complete answer that we're keeping track of from here. So that's what we're doing. So um, it doesn't need to remember or do any expression right here. it will do it inside this parameter. Okay, so a little bit kind of like, huh? Okay, so let's do this. So yeah, we're done, and let's compile this. Oh, we are calling a different function. Okay, left, and it should be the same. So there you go. So the basic difference is it this one overwrite um, and keep track of the number only, right? The result, as you can see, 1, 4, 12, 24, right? As the n number, which is 4, it equal uh, it decrease, it keep track of the factorial of the 4, right? Just like 1 times 4 and 3 times 4 is 12, so it keep track of that number here. And after that, the 2 times 12 is 24. So at the end, we just return that, only that number, the result, right? And that's it for the tail recursive. Very different. And it doesn't even have to go back to where it came from. It just returned the answer. And that's our solutions for these two recursive functions.